We are enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. In this particular video, we will look at something called 5-letter presentation. First, let's understand what is it, how does it help, and then see how we can do it in our program, because it's also pretty cool and really good programming exercise. Sometimes we want to present our secret messages in a standardized uppercase 5-letter format. For example, a message may look something like this. Now notice each of these is obviously uppercase, capital letters, groups of 5 followed by a space, groups of 5 followed by a space, and so on and so forth. Now, why do we do this? Well, basically having a standardized form prevents any mistake due to number of spaces, because sometimes, remember, we have spaces, two spaces might look like one space might look like two, and so on, and that may cause a lot of problem. Also, notice when you see a message of this sort, it does not give away the length of the words of the original text. Now, this itself is quite important, because sometimes looking at the context of the situation, by just seeing the length of each of every word, let's say people may be able to guess what the message was, and that's not what you want, right? So this thing completely takes it out. Now, this is of course particularly useful in case of substitution ciphers, where we do not jumble up the letters, we just interchange letters. We rather substitute letters with a new letter. So in that situation is particularly useful, but even in case of, let's say, transposition, this is helpful. So let's see how we do this. In fact, there are a few steps that we need to follow. First thing first, we are going to extract out all the spaces from the original message. Now, why do we do this? Well, because remember, we are doing transposition. If we leave the spaces in there, then these spaces are going to end up in the coded messages as well. So we just remove them. In fact, you can extend this to extract all punctuation. So, no comma, no full stop. And you will see that even though we do this, when these messages are meant for humans, in fact, we can understand still what the intent was, right? So we will basically do the first step of removing all the spaces. But then the problem is that once I remove the spaces, sometimes I may not have the right length for this. For example, for my even odd swap, I want the message to be even length. If I do not take care of this, my encoding process will go and add a space. And then again, that becomes a problem. So what we need to do is that we need to add some dummy characters so that, the length of the message becomes okay. Now, obviously, what length do we need? That depends on the encoding we are doing. So we just need to add some, be cognizant of that and add dummy characters accordingly. Now, dummy characters could be randomly chosen letters, could be, anything. We will look at how we can just use the last letter of the message to as a dummy character, right? So that, once it's decoded, we still understand what's going on. Now we send this, let's say, condensed message into encoding. After encoding, however, we again separate the message into groups of 5. 5 is a standard number. It could be more general, but typically it's 5. And we add a space between every group. For this purpose, we use slicing and loops. And then finally, we convert the message to an uppercase. So these are the steps we are going to follow. Let's just do this, let's say, one by one. So what do I mean by extracting spaces? Well, basically, let's say Python is cool is going to be converted into Python is cool. Notice all the spaces are gone. There may be an attack at 6 p.m. It has become there may be an attack at 6 p.m. Now, the amazing part here is that when humans read this, this is obviously easier to read because, it's nicely spaced out. But even this conveys the meaning. And remember, here the whole purpose is to convey the meaning, rather than having it most grammatically correct and all that. So that's why it's perfectly okay to remove spaces. Now, how do we do this? Well, very simple actually. We use string methods. So what we'll do is to split this entire string into, into a list using space as the demarcation. So basically, every time there's a space, it will create a new element. So this will become a list, and then I just go through the list and keep adding to let's say to a string, right? And append it here. So let's do this first, and we can see this in action. So for example, I go in here into my code and I say, okay, let me just write a function to say, well, define, let's say, extract, say, spaces, for a message. So I just split this message. Like I said, list of words is equal to message dot split. I must use a space. Now make sure there's a single space over there, not zero space. And I'm going to say, look, s is an empty string here. I'm just going to say for words, say words in list of words, right? So again, I'm just iterating over that list. And what I do is that I just keep appending this to the string s, right? And if I do this, Of course, I must return S. I return S. So let's just test this thing out. Let's say my message is, say for example, the guy in the red t-shirt is your target. Let's say this is my message. Now I'm going to extract the spaces from this. So I just say MSG, say no space is given by, let's say, extract, say spaces and MSG. And this will, if I look at, let's say, message no space, basically notice all the spaces have been removed and this still reads the guy in the red t-shirt is your target. Obviously not as easy to read, but still conveys the meaning. So having done this, now remember we need to ask ourselves, is this length now sufficient? Because if not, then the encoding process may add some spaces, right? So now, like I said, there are several choices for dummy characters. We just repeat the last letter. But the question that comes is, what is the right length? Well, so the question that comes up is, what is the right length? Well, that really depends on the encoding that we are using. For example, even or swap, multiple of 2 is what we need. For reversing, there's no such constraint. For swap middle, where we split this, the sentence into 2 parts, obviously the message must be multiple of 2. In the general case, where we have a multiple, let's say we split the sentence into, say, n parts, then the message must be multiple of n. In case of, let's say, generalized even or not, it must be multiple of n. This time around, the n is the length of the chunk. Transpose and transpose general, message must be multiple of n, where every nth letter is being grouped together. For rail fence cipher, it must be multiple of 2n minus 2, where n is the number of rails. Now, there are videos explaining each of these schemes in quite a lot of detail. Please look at that. These are available in the enhancement section. Look at these so you'll understand how these numbers are coming up. But, we can just build a general function where we pass, let's say, the multiple that we need as an argument and let it fill up the let's say put the dummy characters. Now before moving further, notice that for Caesar cipher, which is substitution, there's in fact no restriction of the length because we do not change the length through the encoding process. Now how do I do this? Well, again, I'm going to design a function. Like I said, n is determined from the kind of encoding we are doing. Basically, what I do is I first figure out if this message is already not in the right length. If not, then here notice what I'm doing is to just add the last character, repeat it so that the message becomes with the last character gets repeated. So let's just do this code as well. So I go and say here def, let's say add, say add dummy char message say comma n, let's say n. All right. Now here, so I just say s is equal to, say, message, and I ask myself this question. Well, if len of, let's say, so if, say, len of message is not a multiple of n. Now remember, n will depend on the encoding, so I assume that somebody has decided what n they need. So I just go and say if length is not equal to 0, which means the message is not of the right length, I must add something. So I just go and say is the message plus, let's say, n minus len of message, percentage n, exactly like what we were adding spaces previously. So here I'm just going to say, look, I'm going to add the last character of the message that you sent me, and I do that by just saying message -1. Now notice this is indexing of the string with a negative a negative index, so that will give me the last character. And anyway, once I've done this, so I just can say return, for example, s. Now I will run this code, and like I said, so let's just do this again. And now I need to see, what is my length of, say, msg, let's say no space. Well, it's 32 in this case. Let's say I want to do, I want it to be multiple of 5. So what I can do is that I can say add, say, dummy. Okay, so let's just say msg dummy, let's just say add, say, dummy character. Well, let's say msg no space and let's say 5. So it's going to add. So if I look at msg dummy, it's going to basically repeat the last letter. So notice it says the guy in the red t-shirt is your target. Now again, notice that a human being reading this will understand that this is dummy and is going to ignore it. So still the message will get through. And that's the whole purpose, right? Now, of course, you could have done this differently. You could have said, okay, for example, let's say if I said, say 6, then I get a different MSG dummy because it would have had a different number of, the characters added would have been different. And that's just because, depending on what n I'm giving. Now, moving forward, I'm going to, do the last part of this, which is to say that, okay, look, let me encode this whole thing. And once I've encoded this, then let me insert the spaces back. So we will first have to encode, but anyway, let's just write this, this function in place anyway, so then it becomes clear. So I said def, let's say insert spaces. So here my parameters are, my inputs are message and let's say n. The idea here really is that, we want to group this message into groups of n and add spaces in between. So I first make sure that the message itself is, is of the right length. In fact, I can just copy this piece of code, except that I will not do, I will just put a space over here. Right now, notice that this will not influence in any way the readability of the message, because these are just trailing spaces which will just disappear, practically not be visible at all, right? Now, having done this, I'm going to let's say, so let's just do this on the message, message. Now, so I go and say, for example, s is equal to, say, an empty string. Now here I just say for, let's say, kk in range, and the range that I must, kk in range, I must do int of, let's say, len message message by n. Right now, this must be the range that I must be running this on. And what I'm going to do really is slicing this. So I say s equal to s plus, say, message, s equals to s plus message. So I'll do kk times n until, say, kk plus 1 times n in steps of 1, right? So this is basically a contiguous chunk of, message, and I'm just going to add a space over here so that every chunk, after that there's a space. And finally, I just go and return, for example, return, let's say, s dot upper. Now this is really, really interesting because, so when I run this, now let's say let me just go back to my original message. So my x is, let's say, meet me in the lobby at 6 p.m. Now I'm just going to say x. So x, let's say, no space is, say, given by extract, say, spaces x. So that's my x, no spaces. Notice it has condensed everything. Meet me in the lobby at 6 p.m. Now I look at, let's say, length of x ns. I notice that this is an odd number, so let me just extend this a little bit. So I say, okay, x ns, let's say, extend is given by, say, add, say, dummy character, and in this case I'm just going to say x ns, and I'll give 2 because I want to do, let's say, an even odd swap. So I just want to make it an even number. Now my x, so x ns e becomes an extra m over here. I'm going to encode this. So let's say x encode. Let's say, just say, encoded en, and this is given by, let's say, even odd, say, swap of, say, x ns e. Notice this is now, this is my encoded message. You can see that even odd swap has happened on this, but I want to present this in the 5-letter format. So I just go and say x, let's say, 5 is, say, insert, insert, say, spaces, say, x en and 5, and this will look really cool because if I look at x5 now, notice it looks quite interesting, right? And it suddenly looks like, the even odd swap nature of this is in fact a little bit harder to pick up from here. Let's take one more example where we can use another encoding. Let's just say I did, my x ns, remember, was x no space, which is this. Now if I wanted to do, let's say, a transpose with, let's say, n of, say, 6, right? So if I were to, extend the length of this. So I just go and say, for example, let me just extend the length of this. Now I want the n to be 6, for example, in transpose. So I enter 6. So if I look at x and se now, notice there have been 3 n's that have been added, m's that have been added. Now I'm going to just follow my previous notation. Let's say instead of doing even or swap, I go and do say transpose, transpose. Now I've defined this function elsewhere. I'm linking the video to this, so you can take a look how this goes. But I have transpose function defined over here, and with a index of 6. So I do this. Now x encode is this much. Now remember, I will insert spaces again in this. So I say x5 is equal to, say, insert spaces xen 5, because again this groups of 5 is what I want. And if I look at x5 now, it looks quite interesting again, right? So this is how we get a 5 number presentation. Looks pretty cool. I hope you found this useful. In general, if you think that this way of learning helps you, look at our website, because we have many such activities. Take care. Thank you so much. Bye bye.